Alright, so this is the first video in a series of videos walking you through the different aspects of multiple linear regression. So in this case, we're thinking about multiple linear regression in the context of having a numerical and a categorical explanatory variable. In this case, we're thinking about transitioning our simple linear regression line, so we have one line modeling the relationship between our numerical explanatory variable and our numerical response, and allowing for that line to differ based off of the different groups of a categorical variable. So the Modern Dive book explains this in the context of the evaluation data from the University of Texas at Austin. So these are data that were collected on different professors at the University of Texas at Austin, and they specifically explore the relationship between age and course evaluation score, and here we're explaining the relationship between average beauty score and course evaluation score. So if you're interested in modeling this relationship, we could use average beauty score as our quantitative explanatory variable, and course evaluation score as our quantitative response. We can plot this relationship using a scatter plot, and we can draw this linear trend line through this relationship. We see it's not a strong relationship, but it is present. It seems like it's a fairly weak relationship, but it does have an upward sloping line, so that implies that if you are on average more beautiful, then you are on average going to have a higher course evaluation score. So what this does is it tells us about this relationship, but it might leave us asking questions about, well, what does this relationship look like for different groups in our data set? When we think about groups, we think about the categorical variables that we have available in our data set. So one variable that's available in this data set that is categorical is the data is a variable measured on the sex that the professor identified as. They only gave two options for these professors, so we have female professors and male professors. And so what we did is I am plotting this scatter plot now, allowing for the colors of the points to be differentiated from the sex that the professor identified as. And we have two different regression lines now, one for female professors and one for male professors. And I've imposed the original linear regression line here. So it makes a whole lot of sense that this linear regression line kind of falls as the average between the two regression lines. But as soon as we split apart these groups, we see that that relationship is slightly different depending upon the sex that the professor identifies as. It looks like the relationship is far more flat if you are a professor who is female, where there's almost no relationship going on between whether you are ranked as more beautiful in your course evaluation score. So it almost looks like there's really no linear relationship going on there, that slope is almost zero. Versus for male professors, we do see this slightly larger slope, so that's a little bit more steep, implying that on average, if you're a little bit more beautiful, you're going to have a slightly higher average course evaluation score. So this gives you an idea of how we can use a categorical explanatory variable in these models. So this is a categorical variable that only has two levels, so we only have female and male professors, but we could do this in the context of categorical variables that have any amount of levels. There's also a categorical variable in these data regarding the ethnicity and the race of the professor, which has far more than just two levels to it. So we could have done something similar where we allowed for this relationship between beauty score and course evaluation score to change based off of the race of the professor, and then we end up with maybe 4 or 5 different lines, but it's the same idea where we're allowing for the line to change based off of the group that the observation falls into. We'll talk a little bit more about how we're allowing these lines to change a little bit later. So in the next video, I'll talk a little bit more about how we could use a quantitative variable instead of a categorical variable, so we have two quantitative variables in our regression model.